Hello, my name is Mohammed Al-Adwani and I'm a PhD student at MIT. The course project I'm doing for 1.125 is understanding California's earthquakes and trying to come up with some parameters that may contribute in predicting earthquakes. Earthquake prediction has long been the holy grail for seismologists around the world. The various factors affecting earthquakes are far from being understood, and there exist no known correlations between large-scale earthquake activity and periodic geological events. The goal of this project is to say something about earthquakes' locations, times, or magnitudes from the data available in the IRIS repository. Here we have plots of California's earthquake locations using Google Map. The right figure is accompanied by magnitude coloring in unit increments. It's clear from the plot that earthquakes are restricted in a region which somewhat looks like a spoon, and that's our first observation. So the region is here and here. In this video, we display a time series evolution for earthquakes locations from 1990 until 2015. From the video, we can see that earthquakes in the 1990s occur more densely near the Los Angeles region and propagates north into two lines that are almost parallel. Here on the left, we have a figure that shows fault maps in California. This figure was screen captured from the ArcGIS website. The longitudes and latitudes of the corners of the figure on the left were needed so that we can plot earthquake data into them. In these plots, we can see clearly that earthquake locations coincide with the fault locations in California. In addition, earthquakes happen more often in areas where spacing between fault lines is narrow. So, for example, here the spacing between consecutive fault lines is large and we don't have a lot of earthquakes here. Unlike this region here, we have a lot of earthquakes, but the spacing between consecutive fault lines is narrow. Now we clustered earthquakes via the K-mean algorithm with 7 clusters. Even with 5 clusters, we observed that K-mean centers coincide with fault lines in California. Also, some K-mean centers don't change location much while varying the number of clusters and stay near some major faults. So for example, for this K-mean center, even if we do 5 clusters, this K-mean center is always close to this fault line. So this suggests that only few faults may be needed to capture the entire story behind earthquake events. Now we do the same thing as the previous slide, but with 3 clusters. The K-mean centers appear to lie in the same line. This suggests the California earthquake problem seems to be symmetric in terms of location. In this video, we study the dependence of consecutive earthquake intervals, where each interval composes of 100 consecutive earthquake events. From the video that's playing here, we cluster earthquakes in terms of location into 2 clusters. We can see that the K-mean centers change slowly with time. Even with 3 or 4 clusters, the results seem to be consistent and the centers vary slowly. So for the first center, it's usually in this area, and the change is very slow with time. And for the second center, it's somewhat here, and the change can be like predictable. So I'm gonna play it again. So the second center is somewhat here and changes slowly. So we can think of the problem as a continuous problem. So to conclude, in our project we have found that earthquakes occur in specific regions in California. Earthquakes tend to propagate from South to North California. Earthquakes happen more often in areas with narrowly spaced fault lines. The K-mean centers with clusters 5 or more coincide with major fault lines in California. The California's earthquake problem appears to be symmetric in location. The K-mean centers locations, in the case of 4 or less clusters, change slowly with time. Thank you very much.